Hey everybody, and welcome to another video. My name is Elric, and in this video we're going to take apart a procedure that has a recursive CTE in it from AdventureWorks. I've already done the work and I've optimized it in two different ways, so we're going to look at different ways to protect the growth of a recursive CTE and actually a surprise between an inner join and a left join. So I hope you enjoy, and I will see you soon. Alrighty, so the procedure that I'm optimizing is the USP get employee managers from the AdventureWorks database. So what I've done is, what this is a recursive query that is essentially taking an employee ID and going all the way up. So me as an employee looking for my manager, then looking for my manager's manager for another record, and then my manager's manager for a third record, and etc. So one of the main problems with recursive CTEs is that you really can't control the growth. It can spin for a very long time or it can be very quick. So we're looking at a variance in actual execution speed. It might slow down as you get more data, as it has to do more iterations. So I have redesigned this procedure without using any recursion, except I'm changing the model. So a lot of us are familiar with a relationship table. In the sense that we have a parent and a child in a relationship table. So you might have a relationship, cross-ref, junction, bridge, whatever you call it, of person to person. You might have another one of person to product, or group, company to person, company to product. You have all these tables. I've decided to use one of those, period. So no matter if it is person to person or, person to product, whatever, it is still going to reside in this one relationship table. And it's a little hard to understand, but it makes sense. It's really cool, and I'll show it to you in code. So to fill this data, I essentially took that recursive CTE and processed it with two different relationships, one of them being direct and one of them being descend. I was going to do ascend, but I stopped just because. So in this one relationship right now, I have all of the data for a direct relationship between parent to child under the manager to employee relationship, and another relationship, which is everything under a parent. So I don't have to use the recursion itself. So the first way I optimized it was actually using these tables not in a loop. So I have, get all of the descendant relationships for the manager to employee. I'm going to use 50 as an example because I know 50 is an employee that has managers. When we run it, we get 3 records back. So it's basically the child of 50, and these are all in the same relationship as a parent. If I were to say the parent ID is 25 and ran it for the descend relationship type, it's going to show me everybody underneath that parent. So I have a ton of employees because this person is probably way up there, but I do have the distance from. So 0 meaning right under, 1 under 0, 2 under 1, etc. So these are different branches in the group hierarchy. Now I take that descendant relationship and I basically find the direct relationship for that individual. Take my descendant relationship and apply the direct relationship. If that parent coming from this has a parent, let's go ahead and see what their parent is. Because this query is very unique, as it's not show me all of my managers, it's draw me the path. So it's a very specific query. And that is basically it. If it has no child, I understand that it's me. If that person, that manager, has no child in the direct relationship, it's obviously has to be me. So after I do that crazy voodoo magic, all I have to do is join the person's table to get the data I need. The second way I optimize this is through a table where I use a while loop, and not just any sort of while loop, but one that depends on a flag. So it's not counting, it's just a flag. So I get this ID coming in, I say it's an employee ID. So I look up the manager ID through the direct relationship that I have, find my employee first name, last name, my manager first name, last name, and insert it into a table. Now I go into the while loop. Because that manager, or because, that manager ID that I have, I'm going to say you're an employee now. So I make the swap. Okay, so this manager is now an employee and the manager is blank. Let's see if this new employee has a manager. If it doesn't, we're going to trigger and exit the loop. If it does, we're going to find that information and insert it into the table for return. When it hits here, it'll go automatically to the top and do the replacement. The manager's manager is now the employee, etc., until there is no top level and it stops. Then we just select from that data. So I executed with statistics.io and time the original I'll just save these and close these out now. I think it should be the original, the optimized version, and the loop version, the second optimized. So I ran these with statistics.io and time. Now this gets really hard to read in here, so there's this site I like to use called Statistics Parser. It's really awesome. All you do is you paste that output, make sure no count is on. No count is on, and it'll give you the output of the query. All of our scans, all of our logical reads right here. So this is the original procedure. This is Microsoft supplied AdventureWorks procedure. No index modifications outside of what we've done in the last two videos. So I have a scan count of 7, a logical read of 87. The time's whatever for me, because it's really how much work is actually taking place, because the less work, the better it'll actually be. So we have 7 scans and 87 logical reads. Now in the non-loop version, just the inner join, direct or descendant, direct relationship, inner join. What's really crazy is that there are 40,000 logical reads in this particular optimization. And I left it like that because I want to show you something really cool. We have all of these logical reads in this optimized procedure. If we go into this procedure, I know where all of these scans are, or all these logical reads are, and it's right here. Knowing I have a unique set, knowing the data is going to exist, why don't I change the inner to a left join? Execute that. Come back to my optimized, run it again with stats and time, and my logical reads go from 40,000 down to about 60. I actually have that as a 4th item in my list. We went from 7 and 40,000 on an inner join to 37 and 86 on a left join. Syntax matters. Applying different syntaxes very much so matters in optimizing. So you have to be willing to create multiple versions of the same thing just to figure out which one is faster. And the last item, the loop, we performed at 5 and 31. So even if we look at 5 and 31, 16 milliseconds, 37 and 86, wait, is that right? I apologize. Just want to make sure this is right. Yep. 37 and 86 versus 7 and 87. So, you know, the loop or the modified select statements, the descendant and direct and descendant, like that crazy mess, is almost the same as the original procedure. But when we actually go into the loop, into like a cursor-based item, we actually see some improvements. So the bottom line is, I guess, one, when you're optimizing, you really have to create a lot of different ways to accomplish the same task, spend the time to look at those IO outs or IO in times to figure out which is the best solution. Because anyone that sits there and says, you know, cursors are bad, joins are the best, it's like, what kind of joins? Applies, inner, left. I just showed you that an inner and a left, we have completely different logical reads. Not just like 10, but from 40,000 to 12. So spending the time and doing that and ignoring everybody who says one thing is better than the other without providing you proof, without sitting there and saying, you know what, I have done the tests. A self-join versus an any all sum versus a lag lead. Any all sum is slightly better than a lag lead. Inner joins, self-joins, complete garbage. So that's what I kind of wanted to bring up today is as I'm messing around in AdventureWorks, looking for something to modify some different aspects on optimization, just to show you guys that your favorite syntax might not be the best syntax. Learn it all, keep exploring, and all that stuff. So thank you very much for watching. I hope this was a pretty good video for you guys. Like, comment, subscribe, and I will see you in the next one. Have a good one.